Welcome. In this session, we are going to do another example of calculating producers and consumer surplus. This time, Q given as functions of P. The demand curve is Q equals 400 minus P squared. Supply is Q times 60 minus the quantity P minus 5. Again, you can draw the graph and read off the equilibrium point, or we can do this algebraically. Let's find the equilibrium point algebraically. We're solving this system. We set the two things for Q equal to each other. I multiplied out the supply equation, 60p minus 60 times 5. That's how I got this. Again, I have a quadratic equation, so I'm going to put it in standard form. Subtract 400 and add p squared to both sides, which gives me 0 equals p squared plus 60p minus 700. It factors as p plus 70 times p minus 10, and the only positive solution is p equals 10. So that's the equilibrium price. Since the equations are given in the form Q equals something in P, I will use the second set of formulas. To use these, I need to find the smallest price at which there is some supply, the highest price at which there is some demand, P min and P max. So let's go ahead and find those as well. So these are the P-intercepts of the supply and demand equations respectively. Again, I can read it off the graph, also do this algebraically. For the demand equation, Q equals 400 minus P squared. If Q is 0, that's the price intercept, I get the equation 400 minus P squared equals 0. Solve this for P. P squared is 400, and since we have to take the positive solution, I take the positive square root of 400, that's 20. For the supply equation, the intercept is where 60 times P minus 5 is 0, and that happens when P is 5. So again, if I mark the consumers and producers surpluses in the graph, consumer surplus is the area from the horizontal line through the equilibrium to the demand curve. Producer surplus is the area from supply curve to the same horizontal line. We are going to set this up using horizontal strips. The left boundary is Q equals 0. The right boundary for consumer surplus is Q equals 400 minus P squared. P goes from 10 to 20. Or we can use the formula. Equilibrium price P naught is 10. The maximum price at which there is any demand is 20. Demand equation is 400 minus P squared. Integrate that with respect to P. Again, it's a quadratic, so the integration is easy. Apply the power rule term by term, then take the net change. If I do the arithmetic, I get 5,000 over 3. For the producer surplus, the left boundary is still Q equals 0. The right boundary is the straight line, 60 times P minus 5. Or if I multiply it out, 60p minus 300. P goes from 5 to 10. Integral from the lowest possible price at which there is some supply, that's 5. Equilibrium price 10. The supply equation, 60p minus 300. And again, it's a straightforward integration, power rule term by term, then net change gives me 750. This concludes our discussion of producers and consumer surplus.